Hello everyone, my name is Javier and I am here to talk to you about this past year development at ProxySQL team. So, first introductory note, who am I? So, my name is Javier Jaramago Fernández. I am a system engineer working at ProxySQL. For more information, you can refer to my GitHub or GitLab pages. These days, for sure, you're going to find more information in GitLab. So, which one is the goal of this presentation? So my goal was to give you a brief overview of all the features that I considered were more exciting, either by their impact or because they offer interesting insight about ProxySQL itself. Also, I wanted to be able to give you the most interesting, sparkling internal details that I can afford within the context of this talk and the time that we have. So without any further delay, let's just dig into the features. First one, the Prometheus exporter. This is a big feature that was introduced in ProxySQL version 2.1.0. Since this version, ProxySQL includes a built-in Prometheus exporter that currently exposes more than 180 metrics. These metrics are exposed through an HTTP endpoint to be collected by Prometheus and then can be accessed by any other services for the presentation, as for example, Grafana. So, why Prometheus? This leads to some questions, and the first one being, why Prometheus? So Prometheus was chosen for several reasons. First of all, the simplicity of its format, the widespread adoption, and also the availability of third-party exporter libraries that we could shape to our needs. Also, it provided the kind of observability that we were looking for the metrics. This leads to the second question, the API design. Well, since we wanted this to be the primary source of metrics going on for ProxySQL, we wanted to have a very solid API design for them. So there were two key aspects that we cared the most when we designed this API. There were simplicity and performance. For the first of them, for simplicity, we wanted the metric to be just able to be defined as simple in a couple of lines, and also being accessed in an uniform and reliable way through across the whole code base. Because of this, we took an approach of per module defined maps for the metrics. So what is that? This means that for each module, for each ProxySQL module, it should contain the metrics definitions that are exposed from that module. These metrics definitions contained in these maps are then later used during the initialization of the module itself to create arrays that holds the metrics objects themselves, the Prometheus metrics object. And then these metrics objects are the ones that are used to expose the metrics through the exporter. So this approach offers error-prone definition and access of the metrics, because defining it is just adding it to the map, and accessing them is just through the arrays defining the modules that has been already initialized. And also, it's a very fast way of accessing the metrics objects themselves, because they are located inside the arrays that are located within the modules. But since in ProxySQL we care about performance a lot, and we didn't want to spend any extra cost of ProxySQL working threads time for the simple purpose of updating a metric, this approach comes with some downsides, which is that metrics objects for Prometheus exporters are usually atomic. And we didn't want to spend this extra cost for some metrics. So what we did is that we have internal per thread counters for certain metrics that we collect and then update the metrics objects themselves on demand when the endpoint is queried. So this design lets us scale in the number of metrics without worrying about performance at all, and also have the advantage of the simple definition and access that we will talk about before. So this leads to a point that I want to address, which is the comparison between the exporter and the admin interface. So traditionally, all the metrics from ProxySQL and also configuration, etc., is exposed through the admin interface, but it's important to take into account that the exporter is specifically designed for not introducing any locking or any extra work in the current ProxySQL working threads. While the admin interface is not designed with those design considerations in mind. Yes, we try to keep the admin interface as performant as possible and as reasonable, but that isn't the main goal of the admin interface. The main goal of the admin interface is to have a generic configuration tool for getting and accessing the ProxySQL config. But if you need to access metrics about ProxySQL in a tight loop or in short intervals, we really encourage you to use the Prometheus exporter because, unlike the admin interface, it is specifically designed with this purpose and should meet all your requirements regarding ProxySQL metrics gathering. So, together with this feature, we packaged some template Grafana panels that you can check out in this repository. This should serve as an example of how to configure and how to use the exporter. But please don't take it as a source of truth. It's simply a useful resource to take into account when you are first approaching the exporter. Here are some of the Grafana panels that are supplied. One of them exposing several metrics about ProxySQL and the other exposing metrics about the connection pool. And as a final note on the exporter, I wanted to add these very recent metrics additions, just to show that we have a commitment, a long-term commitment of keep adding more metrics to the exporter as we go on. So, for example, you can see the even recent clusters tables that has been introduced in our latest ProxySQL release 2.4.0 are added as a Prometheus metrics. We will talk about those tables later. So this is we move from that, and now we have prepared statement results buffering. This is also a very interesting feature that was also added in ProxySQL 2.10. And in a sense, it is that ProxySQL is able to start sending to the client parts of the result set without the result set has been fully received from the backend. So this matches the previous behavior that we have for text protocols and makes the behavior of ProxySQL homogeneous between the two protocols, and can be controlled via this configuration variable that determines the maximum result size the ProxySQL will buffer before starting to send the result set to the backend. So this feature allows for ProxySQL for a much more steady use of memory on ProxySQL side, even for large queries, and no matter the size of the final result set. So as a conclusion, it's a really useful feature when you don't want to care at all about either the protocol version or the size of the result set that you are going to receive. ProxySQL should just have a steady usage of memory. So now we're moving on to a couple of security-related features. First of them is SPIFFE authentication. Since ProxySQL 2.1.1, SPIFFE authentication was added. Since the initial additions, we have improved support in all the subsequent releases of ProxySQL to the latest 2.40. So briefly, you have there briefly defined what is SPIFFE. I am sure that many of you are already familiar with it. It's a secure production unity framework for everyone, set of open source standard for securely identifying software system in a dynamic and heterogeneous environment. Well, on ProxySQL side, we are going to care about some minimal SPIFFE concepts. We are going to care about the SPIFFE ID. We are going to care about the SVID. So the SPIFFE ID is simply the URI for the workload that we are specifying. The SPIFFE SVID is the SPIFFE verifiable identity document, which is the document which a workload with a workload proves its identity to a resource of or a caller. So it's a document used for a workload to prove its identity. It encodes the SPIFFE ID in a cryptographically verifiable document that by standard has two formats, which is the X509 certificate and a GWT token. In ProxySQL, we just support the format. We support the X509 certificate. So, on ProxySQL side, what we need to care? On ProxySQL side, the first thing what we need to do is to configure the SPIFFE. For using this feature, we need to configure the SPIFFE ID user attribute. So for example, one like the one that we are seeing here. As a small note, since ProxySQL version 2.40, we have added reject support for this SPIFFE IDs. So you can use an SPIFFE ID like the one that you are seeing there, which is an SPIFFE ID which starts with an exclamation point and then is later followed by the rejects that could authenticate against several services as the one with the URIs listed there. So this was the first part. So as a recall, we have said that first we have configured our SPIFFE ID, it's an user attribute in ProxySQL. And now, secondly, the client connection needs to supply the SVID, needs to supply X509 v3 certificate, which can be verified against ProxySQL CA certificate. And which this supplied SVID needs to contain a SAM URI with the same ID as they specify in the user attribute SPIFFE ID. So I want to add a remark here. Note that even if this points to ProxySQL performing a validation of the supply certificate against ProxySQL cert, this doesn't mean that ProxySQL supports MPLS. This check is just performed if the client connection supplies a certificate which holds a SAM URI, identifier which starts with SPIFFE. So in case that condition holds, ProxySQL will perform that verification. Otherwise, it won't. So next security feature also included in version 2.3.0 was multiple TLS improvements. First of them being the client certificate reload. So this feature, in combination with the previous feature that ProxySQL already has, which is the allow of backend certificate renewal, allows for a full certificate renewal without the necessity of restarting ProxySQL. So, before, it was already possible to perform a backend certificate renewal using changing the variables that we see in the screen and then using the command load MySQL variables to runtime. And now, since the new feature is introduced, client certificates can also be reloaded by swapping the files that you can see listed there and using the command that you see listed there, which is ProxySQL reload TLS. Please remember after doing this to check error log in case error log, ProxySQL error log for for verifying that the operation was successful and took place. Also, as a note, the certificates will be used for the new incoming connections. Okay, further TLS improvements. So since version 2.0.0, other keys than RSA can also be used, which, for example, easy keys. Also, certificate revocation list and multiple certificates authorities can also be configured. And since the newest major release 2.4.0, TLS versions can now be explicitly specified, including the deprecated versions TLS version 1 and TLS version 1.1. In case you want to use this deprecated TLS version, ProxySQL will issue a warning since we don't recommend the use. So, another security feature, the client error limit. Also in ProxySQL version 2.0.0, a new feature, client error limit, was introduced. This feature controls the number of connection errors that can be initiated by a particular address before denying any further connections from that particular address, providing a protocol aware of DDoS protection mechanism. So, this feature is controlled by the variables that you can see there. The first one determines the number of errors that any address is allowed to perform before getting banned for any future connections. And the second one is the size of the cache that determines the size of the cache being used for keeping tracks of the client addresses that have had any connection errors. Cache can be cleared by performing the command that you can see there, ProxySQL flush MySQL client host. And then the feature also offers observability through these two stats table, which allows you to see the current status of the cache and also allows you to reset the table, as many other tables. Some technical insights about this. So, cache is checked as soon as the connection is established. Why that? In order to keep the invalid connection time as light as we can, when this feature is enabled, the first check being performed when the connection is established is the cache status. If the client address is found in the cache, connection is denied and the socket is immediately closed without any need for processing authentication or session creation inside ProxySQL. Now we move from these security features that introduced to multiple DGS improvements that have been receiving since 2.1.0. The first one being better replacement for query digest. So now with the aim to produce more homogeneous digest, you can see a number of different replacements that ProxySQL now performs over digest that before it didn't. So you see decimal, floats, spaces, but also we introduced new grouping options like the one that you can see there. MySQL query digest grouping limits allows you to compress any groups of values into the maximum number of values that you think you care about that query, thus allowing to compress heavily the size of the query digest that you are generating. Since for the latest ProxySQL release 2.4.0, multiple corner cases were addressed, multiple bugs were solved. Performance improvements were, as a consequence of the big refactor that we performed, multiple performance improvements were added, were introduced, and also we added a new grouping option. So we start with the new grouping option. If we talked before that we added a new grouping option for compacting groups, for collapsing groups of values, now we add a new grouping option that allows you to compress groups of values. So for example, if you have inserts like the one that you can see there, you can now compress the whole collection of values into a maximum groups of grouping, which allows for even bigger compression as the previous option. Also, in the latest release was a new options was introduced, which is queries digest keeps comment, which allows you to entirely preserve a comment that was added to a comment from the query digest, which is very handy in scenarios in which, for example, you have an issue identifier that you are sending in the query and you want to separate the digest because of the digest using the service identifiers that you are placing there in the comment. Before you will see the identifier lost, and now you can preserve it. The performance improvement. Here are some insights about the refactor that we performed. So the previous parser, the tokenizer that we had, was a refactor from a single pass parser into multi-stage parsing. So the goal here that we have was to reduce the branching because it was a very complex logic, to simplify the logic, to improve user control of parsing, adding more configuration options as the one you're seeing. Also because stages can be disabled themselves just by disabling the previous configuration options that we have seen, and also maximize the digest buffer usage with the compression mechanism. Because as a side note of this compression that we now perform per stages allow us to fit even bigger digest in a small query buffer, as long as the digest the end digest holds in the supplied query buffer, the digest will fit in, unlike in the previous implementation. So all of these changes comes up with a 30% performance increase in several intense benchmarks that we performed. And now we move on from query digest to cluster changes. So we have added multiple improvements recently to cluster, including further table variable synchronization that it was added in ProxySQL version 2.1.0, which are MySQL Galera host group, Replication host group, MySQL Aurora host group. Before, you couldn't rely on clusters to synchronize all that for you, and now you can. The number of things that clusters now syncs is very, very limited. Basically, all ProxySQL relevant configurations should be synchronized by cluster. Version verification, this has to do with the previous feature. Via version verification, now cluster only can work with ProxySQL with another ProxySQL instances which are of the same version. This greatly simplifies the synchronization of all the values of all the possible configurations of ProxySQL. SSL support for intercluster communication, and also, since the latest major release, improved intercluster synchronization resiliency. This was done by several means. First of them, for example, it was the avoiding invalid fetch through cluster nodes through epoch preservation. Also, verification of the pooled configuration from different servers matches the expected configuration, and also reporting of invalid sync states. This also, now we move to some features that came in 2.4.0, specifically about cluster, which these two features that you can see right now are closely related. And now cluster node has a configurable UUID. So this can be configured either by a configuration file, by supplying the command line, or letting it to be automatically generated. These UUIDs are used by the nodes to announce themselves when they connect to another cluster node. So when a cluster node performs a connection to another cluster node, it announces itself using the previously mentioned UUID. So this relates to the second feature that we see here listed, that core nodes are now aware of satellite nodes. So because the concept of cluster nodes and satellite nodes is a concept on how ProxySQL is usually deployed, we are going to check this a little bit in a little deeper way. So here we can see the typical topology in which a ProxySQL cluster is deployed. You can see two layers of configuration, the one in the center being the core nodes and the outer layer being the satellite nodes. So the difference between the two layers is that ProxySQL core nodes are considered the source of truth for the outer layer. This means that satellite nodes push configuration from ProxySQL core nodes, but are not aware of other satellite nodes and don't pull configuration from them. While in contrast, the core nodes are all aware of all the other core nodes, meaning that they monitor each other for configuration change. So, as you can see in this diagram, all the configuration is pulling from the inside layer to the outside layer. And the core nodes are the only one actually being monitored by other nodes, by themselves and by the outer layer. But, since we have talked before, cluster nodes are now aware of satellite nodes. How we and they identify them with the new introduced UUID. But not only with the new introduced UUID, because they also identify them by knowing the hostname, the port, the admin interface, and the last time they saw this satellite node. So why all of this and how this all relates? So the motivation for having cluster node aware of satellite nodes is essentially having better extensibility of the cluster state. So with only a connection to a core node, now we can inspect or introspect the whole cluster state and provide an easy debug experience, because the cluster node is aware, the core node is aware of the other core nodes, as also is aware of all the other nodes that are pulling configuration for him. This is also very useful for monitoring tool creation, because of the previously stated facts. And also, this, as a proof of it, this will be used by our next web UI interface. As always, all the information is available through this table. There are also more tables that has been added through informing about cluster information, but I am not going to mention those. So there is another upcoming feature for cluster, very minor. I wanted to just mention it because I find it really handy. It's the kind of thing that you think where you are developing, which is that we will have coming support for release and build compatibility in cluster. Right now we don't support it, but we will, and because we think that it will be a very handy feature for the backend. So I want to conclude talking about cluster, encouraging you to watch René's presentation about the topic from past FOSDEM, because he covered cluster in a much deeper way and presents you with nicer examples, with practices that we have observed about it, taking more time into the details that I have just done. So please, if you're interested, just watch out for that presentation. So we move from cluster and we move to client deprecate UF support. This is a big one. This is a big one because it's a protocol change. And it's a protocol change that was introduced in MySQL 5.7.5. Essentially, it's the deprecation of the EOF packets in favor of OK packets. So what is the motivation for a protocol change like this? So the motivation is that OK packets are extensible. Via that extensibility, you can use it for supporting things like client session track. As a real-world example of this, in Shopify, they were doing a very interesting use case of it by sending back performance metrics from inside the databases using this capability. So, what are the ProxySQL side changes of this? Well, as ProxySQL itself being a client and being a server, for MySQL, this offers a challenge on both sides of the proxy. First, and a very big challenge was that the protocol wasn't supported by the connector that we use for the backend connections, which is lib and the client. As you can imagine, this as itself is a big deal. And supposedly the first step of the challenge. And as second and later stages of the challenge, multiple modules were affected by the change. As an example of them, especially supported commands, so the commands that we intercept and we need to reply, but some of them are required to be aware of the protocol change for performing for sending the correct results. Also, query cache is affected, capability trackers, etc. The propagation of these changes represented also testing challenge, especially because at protocol level, different connectors do behave differently. So it was a hard one, but we can say that ProxySQL supports now clean deprecation EOF. So very happy about that. So now we move on to some final compatibility improvement features. I wanted to add this because let me talk about some ProxySQL insights. So the first one will be the added support for HA proxy MySQL health checks. This is an interesting one. So in short, there are some facts about that are important to remember to understand the issue. So first about ProxySQL data flow check. So ProxySQL never expects data on both sides from a SQL data stream, which is the communication channel, let's say, with the client. HA proxy health checks are composed by an auth request and a conquit packet, and they are sent together. And also, HA proxy doesn't wait for the greeting message. So in the SQL protocol, there is a greeting message, and then you reply to the greeting message with whatever response is proceed. But HA proxy basically ignores it, which is it results in a communication like this. So HA proxy doesn't perform any wait to the greeting message received by ProxySQL and performs an out request and a conquit, and then start waiting. So this can have this side effect of this taking place, or this scenario taking place. That ProxySQL says that as at both ends of this data stream. So due to the no waiting of HA proxy under certain timing conditions, ProxySQL could find both the greeting message and the auth request plus conquit packet in the MySQL data stream, breaking so the data flow checks that ProxySQL have. This situation has been handled, and now HA proxy health checks are supported. So, but there is a couple of side notes that are worth mentioning. Depending on the protocol version, depending on HA proxy version, out packet can be protocol handshake response 320. This is a very old and unsupported by ProxySQL. In recent versions, HA proxy has defaulted to handshake response 41, and no action whatsoever is required by the user. But if you find yourself using an older version of HA proxy, then you will be required to use the post 41 configuration option for MySQL health checks. And then for the latest, the final compatibility feature, we have JDBC query batching. So what is JDBC query batching? The JDBC connector offers a feature that allows to batch multiple queries, DMLs, and send them in parallel to the MySQL server. This is performed by sending the queries without waiting for the typical server response, which in this case of these queries are OK packets. This response, this behavior is incompatible with ProxySQL since it breaks the expected packet flow. This is ProxySQL receives the next request from the client while processing the previous request. And that's not allowed. It's not allowed to receive a request from the client while ProxySQL is still processing the query. So this leads us to the first question, like, is this a configurable behavior in JDBC? The answer is historically, yes. So historically, this was configurable via use batch multisend. But this was deprecated in versions in 3.0.0. So only for all the versions that 3.0.0, this can be disabled via that configuration. So that answers with the question, what we do now? So now that the option is no longer present, JDBC decides whether or not to perform this query batching based on other protocol checks, flags checks that he performs. Because of this, our solution is that we plan to add support for this behavior to ensure JDBC compatibility. But as a acceleration, what we plan to do is to add support for receiving parallel requests for clients, which leads me to my final note, which is that queries will still be processed in sequence, yet we will allow the parallel reception of them. Now we move to a very interesting feature that is coming probably to the next major ProxySQL release, and this is the QPS limit rules. Essentially, this feature will allow to throttle the amount of QPS that you can impose, that will allow you to impose QPS limit based on several criteria, which are username, schema name, and flagging. That correlates with the flag out applied specified in the MySQL query rules step. So, how will you control this feature? So the feature will be controlled by a new table, which will be called MySQL QPS limit rules, that will have two configuration values for controlling the matching query. Will be QPS limit, which is the desired QPS limit to impose for the matching query, and the bucket size, which is the vastness or variation that are allowed for that QPS limit that you have imposed. Alternatively, this can be called as depth of the token bucket. For more information about how these two parameters relate and how can you get the most out of them, you can refer to the token bucket algorithm, because it's the one that is going to be used under the hood for this implementation. So I am jumping now to conclusions. This is the list of features we have the time to go through. As you have seen, there has been a lot packed in the most recent major release of ProxySQL 2.4.0, and I really encourage you to give it a try and to check it out. Also, I have an asterisk there in the minor version number because I wanted to have a side note to clarify how we do minor releases. So we have seen that multiple times our users use the major release and never get to upgrade from the major release to a minor release from that major. And I just wanted to say that we try to be very conservative in any mirror release. We only pack bug fixes in them. There are iterations in which we want just to pack the things for to pack the things that iterate towards the best experience of the features that we have packed in that measure. So I really encourage you to upgrade to the minor release that we keep releasing, because they are just improved minor improvements over the features that we have released in the major. We never pack anything big there. There are very exciting features to come for the new 2.5.0, as the previous one that I have mentioned, and some others that I don't have the time to go through. And we are also very excited about the coming year and what is to come. Finally, I would like to thank you a lot for your attention. It has been my pleasure to be part of this conference. I will also have a final thanks to the ProxySQL community for this amazing year. I hope that we can have another one submit like this, the next one. And that's it. Thank you. Thank you, everyone.